Welcome back, students. We have already discussed about that Rtos based embedded system introduction. Next, we are going to discuss interrupt handling of an Rtos. Okay. This is interrupt routines in Rtos. We are going to discuss what is interrupt. Interrupt is a disturbance given by a hardware or a software to the process through operating system to do the operations first. Okay, so interrupts is a mechanism for alleviating the delay caused by uncertainty and for maximizing the system performance. Okay, instead of polling the device of devices are entering into a wait state, the CPU continuously executing the instruction and performing the useful task. For example, if you are writing some tests, let me take that as an example. If you are writing a test, during when you are writing the test, there is an interruption from the hall supervisor. That is, you have to complete the you have to enter the attendance, you have to sign in the attendance. That is an interrupt given by the hall supervisor. So you have to give priority to the interruption given by the hall supervisor before completing your exam. You have to sign in the attendance. So you stop writing the process, you keep it aside, and then you check whether your name is there in the attendance, and in that line you have to sign, and then you have to get sign from the hall supervisor. Then you will continue writing the test. Okay, this is the general process. The same thing is happening here also. Your microprocessor is doing some work. Okay, see that one in the diagram itself. Your CPU is doing some work. It is executing a program. During the execution of the program, there is an interrupt request given by the IO device. When an interrupt request is given to the IO CPU, it complete the current status. Okay, current execution of a code. After completing that one, it will save the necessary things in that stack. After that one, it gives an acknowledgement to the interrupt. After that one, the interrupt routine will be executed. After completion of the interrupt routine, it will come back to the previous position and it will continue its execution. CPU will continue its execution. That is the general interrupt and its operation. Okay. Scenario of interrupt service routine in Rtos. In Rtos also, this is the general routine in operating system. In Rtos also same thing is happening. Embedded applications running on the top of real-time operating system require interrupt service routines. To operate that interrupt, there should be an interrupt service routine. What operation has to be done when there is a request? For example, when you are doing a process, we have already discussed that example now. When you are using that room temperature controller, there you are using a fan and an AC and a heater. Okay, when the temperature is high, that time you are receiving an interrupt through the sensor, that is the temperature is above 20. If the temperature is above 20, you have to switch on the AC. So there should be a separate program that should be executed to switch on the AC. Okay, that programs has to be executed that should switch on the AC. That is the set of codes that should be executed when an interrupt is given, means that is a subroutine or sub service routine in the program. Okay, so that should be executed first. After that is executed, then only the processor, that is CPU, will continue its current program. Okay, interrupt. In handling the interrupt itself, we are having three types of handling. That is, either an ISR may call the either direct call to an ISR. If you are having some interrupt, directly the hardware interrupt will directly call the ISR. From the ISR, there is a request given to the Rtos. There is an information passed to the Rtos, and then from the Rtos, the other process will be takes place. That is direct call. Second one is Rtos first interrupted by an interrupt. Okay, then it initiates the ISR. Third one is Rtos first interrupt and interrupt, then Rtos initiating the ISR, then the ISR will execute it. Okay. Let me start with that first one. Direct call to an ISR by an interrupting source, and the ISR sending an enter message. See that one. Here we are having two memory blocks. Okay, the CPU here, that under that one you are having a CPU now. So this CPU is here, the CPU, the OS is executing a set of program. During that execution of the program, there is a request given directly to the ISR. Okay, from the ISR it gives a request to the OS. Okay, it gives an information, there is a interrupt given to me, that is entered in the ISR start message. Then after that one, the ISR start executing that one. It takes the control of the CPU and it start executing that one. After completing the process, it gives a return information to the OS. So then the OS will continue its process. Okay, this is how we are doing that in the ISR call. Okay, here the ISR is called by the interrupt directly. Okay, next, this is explained in this one. Next, Rtos first interrupting an interrupt, then Rtos calling a corresponding ISR. Okay, here Rtos give an interrupt to the OS first. See that one in the diagram. Here we are having three memory blocks. Okay, here Rtos, your Rtos is executing a program. During the execution, you are receiving an information. See, this is the first one. You are receiving the message. From that message, here I am receiving the interrupt. Okay, this is the interrupt request given, and then for the interrupt request, the processor, that OS, complete the current process, save that one. Then after completing the current process, it gives a request to the ISR, that is the second process. After the ISR receiving that one, it complete the process. After completing that interrupt service routine, it gives the return information. Here that execution takes place with the given codes. Then after completing that one, Rtos is given the information that it has completed that. After completing that one, the process OS will complete the current process, then it initiates the next task. Okay, this is explained in this one. Next, Rtos first interrupting on interrupt, then Rtos initiating the ISR, and then an ISR. Okay, here the two levels of ISR is in Rtos are executed. Fast level ISR, then slow level ISR. Fast level ISR are the hardware interrupts given, hardware interrupt ISRs, and slow level ISR are the software interrupts. That is what is software interrupt means. When you are explain about that one, when you are executing a program, that is that example we have discussed now, in a room temperature controller, when the temperature is above 20 degrees Celsius, it automatically switch on the AC. Okay ma? So when the temperature is above 20 degrees Celsius, there is an interrupt given to the Rtos. So the Rtos initiates the ISR, then ISR complete the process, it switch on the AC, then it will continue the process. Okay, this is a type of hardware interrupt, and that is fast level ISR. Okay, the same thing, in the same time when you are executing a program. Okay, during the execution of the process, your Rtos is executing some program. We have discussed the threads and process. Now inside a process there are so many threads. If a thread is waiting for the source, okay, so the source has to be right in that time. If it is waiting for the source, that time it gives an interrupt. Okay, that interrupt is called as software interrupt. Okay, if a thread inside the software is interrupt the processor means, OS means, that is called as software interrupt. That time the OS initiates the ISR. Okay, then the ISR will be executed, then it will be completed process. This is what slow level ISR. Okay, this is explained here. Okay, so with that we have completed the interrupt routines in the ISR. If you are having doubt, please feel free to